I would like to present my side project to the game Pensieve. And I want to take you through everything, starting with the problem. Now, I have a sizable collection of video games, and if you're familiar with video games, you will be able to better follow along. But if not, then this is a test of my communication skills. A lot of job postings that I read through have the requirement can be able to explain technical problems to non-technical stakeholders. And this is essentially what I'm trying to demonstrate. If you are not familiar with video games, can I explain to you a problem that I have with my video game collection and have you understand it all the way through the presentation? So, let me know how I do at the end. My games come in two different forms. There are physical games, which are games that appear on my shelf, and there are also digital games. And digital games are only found on the system that they can be played on. So I have a Nintendo Switch, and there are some games that only appear on my Nintendo Switch. I also have a PlayStation, and there are some games that only appear on the PlayStation. But I want a single place where I can view and search through my entire game collection. I built this system, but then ran into this curveball. How many games are pictured here? We'll run through a little activity so I can explain. Well, the first one's really easy. There are 3 games up there. You can count them. 3 games. Now, how many games are pictured here? Now, there's also 3 games here. You can see with the cartridge on the left, it has Super Mario Bros. And Duck Hunt, whereas the cartridge on the right has Tetris. So here we have games that are compilations or collections of other games, and that's going to run into a curveball later. So how many games are pictured here? Well, it's also 3 games again, but as you can probably tell, the Collection of Mana game has 3 other games in it: Secret of Mana, Trials of Mana, and Final Fantasy Adventure. So if we come back here, we can see that Secret of Mana and Trials of Mana, in this picture listed as Secret of Mana 2, are already in my collection on a different system. And Collection of Mana I purchased because it has Final Fantasy Adventure on it and I wanted to play it. So when I look at a list of my games, I want to eliminate the duplicates across the different systems, but I also want to know where I can play that game. If I search Secret of Mana, I want to be able to know that I can play this on the Super Nintendo and the Nintendo Switch. So the real question is, how many games are pictured here? This is a picture of all the physical games in my collection. There are duplicates and there are compilations and collections of games. So, along with this, I also want to include searchable data so that I can ask different questions about my collection. How many of my games can I play on the Nintendo Switch? How many times have I bought Super Mario Bros.? How many games have I beaten? How many games have I purchased but have never played before? I also want to be able to combine these data points to ask even more specific questions, like how many games on my Nintendo Switch have I purchased but never played? So this gives me my finals requirements list as such. First, organize my games to be viewed, including collections and duplicates over different systems. Implement custom data input that can be attached to different games, and be able to filter through that data in order to ask specific questions about my games. Finally, there is a lot of systems I've worked on where we are importing and exporting data, either to or from systems or recreating data from a backup. I've worked on a lot of those before, but I've never created one from scratch. So that gives me the last requirement of being able to back up the data and then recreate the database from that data backup. Here is version 1 of the system. This is a list of all the video games that appear in my collection as they appear on my shelf. But in order to get that extra level of clarity that I was looking for, I had to come up with a different way of viewing the games. So here we have a list of all of the games that are in my collection, and it eliminates all the duplicates that are found across different systems, and it also allows me to run different filter requests on them. So if I wanted to say, give me all the games that have Super Mario in the title, it looks like I have 24 games, and here I can open up Super Mario Brothers, and we can see that down here I have it in my collection 1, 2, 3, 4, 5 different times. So I'm also able to go back, open up the filters, and say, show me all the games on this Switch where I have purchased them and not beaten them. So that is a backlog status on the completion level. And unfortunately, it looks like that amount is 41 games, and you can see all of those here. So the curveball in my collection came up when I asked the question, where is Final Fantasy Adventure? In that first form of the list, searching Final Fantasy Adventure would not return any results. I would have to specifically search for Collection of Mana, and remember that's where Final Fantasy Adventure was. And that's what caused me to build that second form of the list. In order to accomplish this, I essentially had to decouple the hardware and the software. And since not all games come on cartridges, but all games come in a box, I decided to call the hardware a box and the software a game. So in this case, we have the Secret of Mana cartridge, which is the box with ID 10 in the system, and the game, Secret of Mana, has ID 17 in the system. This solved my problem of the compilations. Now, if I have a game that is a compilation of other games, I can just associate those specific games with it. So on the left, we have Secret of Mana, which has the game Secret of Mana, and on the right, we have Collection of Mana, which also has the game Secret of Mana with the same ID, but also includes Final Fantasy Adventure and Trials of Mana. I've implemented custom fields that can be attached to any entity in the system, so I can have different custom fields for the boxes and the games, and they can show different information, and then I can ask different questions based on what's more appropriate. Now for filters, I'm getting a little bit more technical here, but when you're requesting information from the system, you can include a filter object in it. That filter object is then going to get validated and translated into a SQL query that will be run on the database. So if I wanted to find all of the video games in my collection that start with the word super, I would include the filter on the left, and that would get translated into the SQL query on the right. This also works with any custom fields that have been implemented in the system. The system will recognize that that field is a custom field. It will then join the custom fields and their values. And this is also what allows us to include multiple filters in a request so that we can ask those more specific questions like how many games on the Nintendo Switch have I purchased but never played. For the backup and import, I've chosen to take all of the data in the database and export it to a JSON file. Then I can go and wipe out the database, I can rebuild it from scratch, and then hand the system that JSON file, and it will then rebuild all of the data in the database as it was found before. Not exactly, but rebuilt to the point where I can then go ahead and ask those specific questions about it. This part of the system had its own curveballs. It was a really tricky system to implement, but I'm glad that I took the time to learn about it and understand it and get it working. So I want to go real quick over a very high-level design of the system before we jump into the code. We're going to have multiple front ends, so a web UI and a mobile UI. It's going to be able to interact with the backend through an application layer, which will have all of our controllers. We're going to have all of our business logic in the domain layer, and then we'll have a database on the bottom. If we zoom into the backend, we're going to be using hexagonal architecture. That just means that layers can only communicate with the layers that are right next to them. You'll never have a UI accessing the database or a controller trying to access the database. All of the requests are going to go from the UI through a controller to the domain and then through to the database. And this layer design is inspired by domain-driven design. I'm a big fan of including that in all of the projects that I work on. Zooming in a little bit more, the domain is where we're going to have all of our business logic. I have created interfaces. Initially, these interfaces were created to keep me consistent as I was implementing new entities and objects into the system. I have found that this is even better now that I've included some AI agentic coding assistance with me, so that when I say we're going to be building a new entity, it must also adhere to the existing interfaces. So not only am I consistent, but my AI code assistant is also consistent as we're creating new things and new features in the system. So this brings up coding assistance. Claude Code is currently my favorite, but I do try to experiment with other agents and models when I get the chance. In my opinion, what makes LLMs so powerful for coding is that we can define when a project is done much better than for other tasks that might be passed to an LLM. So to accomplish this, I include documentation and notes on the project inside the code base, and I also include a robust test suite. So when I'm creating a new feature for this system, I'll put Claude into plan mode, and I'll start describing the feature that we want to build. As we're going through, I will remind Claude that there are interfaces that must be adhered to. And as we're building, the first thing that we do is we create tests. Now there's two things that this accomplishes. First, by building the tests, it forces me to consider all of the edge cases and make sure that I have good coverage of the feature that I'm wanting to build. But number two, I can read the tests that Claude is generating, and that helps me understand that Claude understands the problem as I want it to be solved and as I want it to be built. So once I'm satisfied with all of the tests that have been generated, then I can unleash Claude, have it go build, and I will say specifically, keep building until the code compiles and all of the tests are passing. Not only the tests that we just wrote, but also any old existing tests that are in the system. Once that's all done, I can perform a quick manual test to make sure that everything was built correctly and then merge it straight into master. All right, so now I want to take you through the code base. That's what this whole thing has been all about. But I don't want to spend a lot of time here because the code base is changing. And by the time you get to look at it, it might not look the same as right now. But I do want to illustrate how that corresponds to those diagrams that I was showing before. So here we have our integration test for specifically getting video games with filters. So we're setting up our video games and our video game boxes. And then we're going to send this to our search endpoint. That's going to bring us to the video game controller. And we're then going to pass that to the get with filters function on our gateway, which will take us here. That's going to get passed down to the service, specifically the video game service. And this request is going to get passed to the entity repository. So in this case, it's specifically going to be the video game repository. From here, we're going to take those filter objects. We're going to send those to the filter service, get those validated, make sure that we get the right SQL back from it. And then we're going to run that. And then we will pass that information back up to the video game service, where it's going to go ahead and get any related objects that have to do with that video game, like systems and custom fields. And then we'll pass that back up and then get that checked by our test to make sure that we're getting the response back. And so if we make any changes, we want to make sure that we don't break this test. If we did, then we need to make sure that's deliberate. So future plans for this project include building a mobile UI. As you can see, the web UI has been built, but I do want to make changes there. I do want to create a different service to implement images into the project. And I do want to wrap the whole thing in an authentication middleware and then perform a wider release so that more people can use the system. But there is an existing system. If you would like to pull this down and run tests and just play with it a bit, you don't need to clone the project. There are containers that are currently hosted on Docker Hub that you can pull down and run them locally. If you would like to do this, just follow the directions in the README file. So that was my side project. I presented the problem, the curveballs that came up, how it led to the existing requirements. I presented my solution, a high-level overview of the system design and how it meets those requirements. And then I guided you through the code base so that even if you are unfamiliar with Java, you can see how the logic is implemented. At this point, there is a code base that can be gone over. I'm ready to answer any follow-up questions, like why I built something in a certain way or if there were any trade-offs that I considered. Now, there is a bonus here. I've noticed that a lot of job descriptions that are asking for engineers with 10 years of experience or more ask for engineers that are specifically self-driven, require little oversight, or embody extreme ownership when it comes to their work. And I can't think of a better example of being self-driven or having extreme ownership than creating a side project like this and then putting it on the internet as a YouTube video. And I love talking about this side project that I've made. So thank you so much for watching. Bye.